Hello and welcome back to Calculus 1. This is a short section on inverse trig derivatives. We have 6 trigonometric functions, therefore we have 6 inverse trig functions. If you're interested in derivation for these, they are included in a book. We are going to take a look at the formulas. Some formulas are more important than others because they show more frequently. Make sure you know the formulas, and all you do is you get to plug those functions where they belong, and you're done. So let's list these, and as I said, in our honors sections we do derivation and all of these things. If you're interested, you can look into it, stop by office hours. I'm just going to list the formulas and we go from there. So the first one is going to be the derivative of inverse sine of x. So this one shows up in Calc 2 differential equations, and this one is 1 over square root of 1 minus x squared. Then we have the other very important formula and frequent formula, inverse tangent. This one is actually the most frequent, the inverse tangent. 1 over 1 plus x squared. And finally, the derivative of inverse secant of x, which is going to be 1 over absolute x square root of x squared minus 1. So as I said, the top two are very important. They show up in many cases in Calc 2 and differential equations. Now, what are the other three? The other three are very easy because they're the same as these, just have minus signs. So derivative of cosine inverse of x is going to be negative 1 square root of 1 minus x squared. So you just put the 1 for the sign and you just put the minus on it. The derivative of, obviously, cotangent is going to be the same as tangent with the minus sign. And finally, cosecant inverse of x is going to be negative 1 divided by absolute x square root of x squared minus 1. So these are the formulas. Now the question is, how do we use these formulas? Well, we can't really use these formulas in this form because this is only for the case when you have sine inverse of x. Generally what we need is sine inverse of f of x, tangent inverse of f of x, right? So it's f of x that floats around. So chain rule version of these formulas is what we actually care about. So if we take a look at the chain rule version, we have to replace those x's with f of x, and because it's a chain rule, we have to multiply by f prime on the derivative side. So the formula for the sine, inverse sine, would change into this. F prime of x divided by square root of 1 minus f squared of x. So the trick is to replace every x that you have on both sides of the formula with f of x, and then multiply by f prime of x in the numerator. So this is your formula for inverse sine, and here's your formula for inverse cosine. For inverse tangent. Like, these are the two that are most frequent. You'll be actually sick of inverse tangent one when you hit certain parts of Calc2 and differential equations. So we have a f prime of x divided by 1 plus f squared. So most of the time, you will be using these two. Maybe I should box them, huh? All right. So what is the derivative of inverse tangent of x squared plus x minus 3? Well, you just plug it in. It's 1 plus x squared plus x minus 3 squared, because in the denominator you have 1 plus the original function squared, and then you have your 2x plus 1 as a derivative in the numerator, and you walk away. That's it. That's all it is. What is the derivative of secant inverse of e to the 3x? Try that one on your own. I will do one more from homework and that's it. So first we have to create the formula, right? We take the old formula and we replace every x with f of x and we multiply by f prime in the numerator. So this would be the f prime of x divided by the absolute value of f of x times the square root of f squared of x minus 1. So that's our formula. And now we know that our f of x, by looking at the problem, is e to the 3x, and we know that our f prime of x is 3e to the 3x. So now we can just plug those things in. The numerator, 3e to the 3x. Denominator, absolute value of e to the 3x times the, over here we have e to the 6x minus 1. Right? Because 3 times 2 is 6. And now these guys would cancel. And the answer is just 3 over the square root of e to the 6x minus 1. That's the way we use this. So let's go and solve one tangent line problem. So what's the tangent line at point, let's say, 1 over root 2 comma pi over 3 for function y equal cosine inverse of x squared. So we have a cosine inverse of x squared. So we are going to do the derivative for inverse cosine. We are going to take the negative, right? So it's the same like inverse sine, it's just a negative. Tako da, so what do we have? We have negative f prime of x divided by the square root of 1 minus f squared of x. Now my f of x is x squared, so my f prime is 2x. Is this doing well? Yeah. Okay. So the derivative dy dx is going to be negative 2x divided by the square root of 1 minus x to the fourth. And now I get to plug in the values. I have m equals negative 2 times 1 over root 2 divided by the square root of 1 minus 1 over root 2 to the fourth power. So this becomes negative 2 over root 2. We'll deal with a double fraction. Divided by 1 minus 1/4. Because the square root of 2 squared is going to give us a 2, and then square one more time, we get a quarter. So this becomes negative 2 over square root of 2 divided by square root of 3 over 2, because it becomes 3/4. Square root of 3 is square root of 3, and square root of 4 is 2. And now when we work out the magic, it becomes negative 4 over square root of 6 as our slope m. So now I have slope m, negative 4 over root 6. We can rationalize this. The root 6. It becomes negative 4 root 6 over 6, which is negative 2 root 6 over 3. So that's our slope. And we have our point, 1 over root 2 and pi. So 1 over root 2 and pi over 2, pi over 3. Pi over 3, which is 2 root 2 and pi over 3 when you rationalize. So now y equal mx plus b. Plug in y, pi over 3. Plug in m, negative 2 root 6 over 3. Plug in x, which is root 2 over 2, plus b. These 2's cancel. So we have pi over 3 plus square root of 12 over 3 equals to b. Now square root of 12 is 3 root 2. No, 2 root 3. Square root of 12 you can write as square root of 4 times 3. So it's just 2 root 3, right? So b is equal to pi over 3 plus 2 root 3 over 3, which is 2 root 3 plus pi, or pi plus whatever, everything over 3. So the tangent line is y equals negative 2 root 6 over 3 x plus 2 root 3 plus pi over 3. Tangent line at 1 over root 2 pi over 3. You can get decimals if you care. Whatever you guys come up with. And that's it. That's the inverse trig functions. So be careful with the replacement for the chain rule, right? To replace function for every x. The red formulas are the 6 inverse trig functions. I did replace f of x for you in these two that are mostly used, but then we practiced all of them, the secants and sines and cosines and so on. So you have plenty of examples to work off, and obviously much more in a book. Let's take a short break. When we come back, the last lesson of chapter 3, 311, related rates, my favorite.